Okay, ladies, so this is in your blue packet on page 14. So, blue page 14. And what we're going to do is we're going to take a look at a graph of first derivative. And since we know how to interpret what a first derivative does, we are going to sketch a graph according to what we see in the first derivative. So, if you take a look at page 14, you'll see this graph here. And if you read it, it says this is the graph of f prime. So that's something very important to know. This is f prime, not f, but f prime. And I go from negative 8 to 7. I know I have a horizontal tangent at x equals 3 and at x is equal to 4, which will be very important for us in here. So x is equal to 3. At negative 3, there's a horizontal tangent. And at x is equal to 4, there's a horizontal tangent. And we know that if it's a horizontal tangent, that means my slope is equal to 0. It says it's twice differentiable, which means I can take a first derivative and a second derivative, and it's telling me that my original graph has to start at f of 0 has to equal 5. So what we'll do is let's take a look at the signs over here, and I'm going to break this apart into the different critical points. So by definition, a critical point is any time our derivative is equal to 0. So I notice there's a 0 right here, a 0 right here, and a 0 right here. So what I'm going to do is I'm going to make sure to list down that my critical numbers are when x is equal to negative 7, 0, and I believe that's 6. Alright, after critical numbers, let's take a look at what that means. And so whenever we take a look at critical numbers, we plug in our test values, find out if it's positive or negative. That tells us if it's increasing or decreasing. So the graph actually does all that work for us. So in this section before negative 7, I notice everything is negative. So I'm going to put negatives over here. And then I notice in the second section up here, everything is positive. Sorry. Okay, I'm sorry about that. So what I notice is everything over here is positive, and then everything in the section down here is negative, and everything up here is positive. So if we interpret that as to what we usually do, we know anytime my first derivative is negative, I'm decreasing. Anytime I'm positive, I'm increasing. And I continue decreasing and increasing. Okay. So that gives us some information. The horizontal tangents also tell us something. Because after we do the first derivative, we also take a look at the second derivative. So second derivative doesn't give us critical numbers, but it gives us possible points of inflection. And a point of inflection is any time the second derivative is equal to 0. Well, isn't the tangent lines, the derivative of the first derivative? So what this is telling us is our points of inflection happen anytime I have a horizontal tangent, which are these two sections. So we know this happens at x is equal to negative 3 and that x is equal to positive 4. So let's go ahead and take a look at the slopes of our first derivative. If you notice, everything up here is going upwards. So we know anything in this section right here before our first point of inflection is positive, which means I am concave up, whereas everything right here is downwards, which means that I am negative and concave down. And then on the last edge, we notice up here we're positive, which is concave up. So we're going to use that to help us graph our function. Okay, so what I'm going to do is, hopefully you guys can see this. Oh no, I undo that? Okay. So you guys have the picture on your table, and this is a little too small. So what we're going to do is, let's take a look and see what this means. It says, find the x-coordinate of each local minimum of the graph of f. Justify your answer. So let's take a look at what a local minimum is. A minimum is when our first derivative changes from down to up, which is negative to positive. Oops. So let's go ahead and take a look at our chart and see, where does our first derivative change from negative to positive? So one area we see that is right here, from negative to positive. So that means this right here, x equals negative 7, has to be a minimum. Another time I go from negative to positive is from here. This is negative, it's positive, so I know right here at x is equal to 6, that is also another minimum. So we're going to say that this happens when x is equal to negative 7 and x is equal to positive 6, since f prime of x changes sign from negative to positive. Okay. So let's go ahead and take a look at the next question and see what it's saying. It says, find the x-coordinate of each of the points of inflection of the graph of f. Justify your answer. So we know a point of inflection, a point of inflection is when the second derivative changes sign. So let's go back and take a look. And we know that our green marks are our second derivatives, green, yellow, and purple. So anytime those change signs, that's how we know we have a point of inflection. So in this first part right up here, we notice that I went from positive to negative. That's a sign change. So I know this is a point of inflection. And then again, I go from negative to positive, which means that this right here is also a point of inflection. So let's go ahead and write that in. Let's just color coordinate here. So I know when x is equal to negative 3 and x is equal to 4, there is a point of inflection since f double prime of x changes signs. Okay. Alright, the next one says, find all intervals on which the graph of f is concave up and has a negative slope. So we know concave up is when our second derivative is greater than 0. We know a negative slope is when our first derivative is less than 0. So let's go ahead and find where that happens. Then we'll write the answer down in this section right here. So I want concave up and I want a negative slope. So I know concave up happens twice, once over here and once over here. Now I have to find where I have a negative slope. So negative slopes happen twice. The first time it happens is over here. The next time it happens is over here. So where am I concave up and decreasing? Then we notice that happens in this section right here. Concave up and decreasing. It also happens in this section right here. Well, actually, right here. Concave up and decreasing. If we take a look, I know that goes from negative infinity to 7, and this goes from 4 to 6. So if we write that in, I say from negative infinity to negative 7 and from 4 to 6. since f prime of x is negative, which means I'm decreasing, and f double prime of x is positive, which means I'm concave up. So we're going to use this information to sketch out our graph, which is part D right here. So we just said I'm all these different pieces, and we also know that f of 0 has to equal 5. Okay? We said we have a minimum at -7 and 6, so I'm just going to put random spots here. -7 and 6, it has to be some kind of minimum. We also said that I have points of inflection at -3 and 4. So around -3 and around -3 and around +4, those are kind of important points. I'm just going to sketch, and this doesn't have to be exactly what we think it may look like, but we're going to take a look. And we said that we were decreasing and concave up in two sections. That was from -infinity to here, so decreasing and concave up. We're also decreasing and concave up from 4 to 6. So 4 to 6 is here, decreasing and concave up. Okay. If we take a look, we are increasing from here to here. And so in order to take a look at that, what we need to do is take a look at our concavity. So I'm increasing this entire time because of this, but what we notice is at -3, I go from concave up to concave down. So what I'm going to do is I'm going to go from concave up to here to concave down. Let's go back to our chart and see what happens next. Once I get here, I'm decreasing, but I have a negative slope. So decreasing means I'm going down, and a decreasing slope means I'm concave down. So that means I go like this. Took care of this part, and so our last part right here is on this side I'm increasing and I'm concave up, which means something like this. So our full sketch should look something to the degree of that purple line. Okay, so that's a possible graph of the original function. So what I'd like you guys to do is go ahead and turn the page over to number 15, and I'd like you to try to solve this problem the same exact way we did this one. Thank you. Good luck.